Hello everyone, I am Livia Croella from Spoke 5 High Quality AI, and today I'm going to run you through my poster, which is a joint work with Veronica Piccialli and Antonio Maria Sudoso, titled Anticlustering for Large-Scale Clustering. Clustering is a fundamental technique used in data analysis for grouping similar data points together. However, when dealing with large-scale dataset, traditional clustering methods can struggle with efficiency and effectiveness. To address this challenge, our work introduces a hybrid approach that integrates clustering with anti-clustering techniques to validate the performance of a clustering method and its solution. Generally, in clustering, we have to minimize the within-group sum of square distances, WSS, effectively grouping together data points that are as homogeneous as possible. Conversely, in anti-clustering, we aim to maximize the WSS by grouping together points that are as heterogeneous as possible. The starting point of our approach is this observation from Dyer in 1985 that states that if we sum the minimum WSS of non-overlapping subset of a dataset, we always obtain a value that is lower or equal to the minimum WSS of the whole dataset. This sum can hence be used as a lower bound on the optimal clustering solution value. Now, if we want to improve this lower bound as much as possible, we should maximize the optimal, hence the minimum WSS of each subset. And how we do that? We can choose subsets that have high dissimilarity and hence solve an anti-clustering problem on the same dataset. To visualize our method, let's consider this example. We have a dataset of 75 points and we have calculated an heuristic solution for the clustering problem, for example, thanks to a k-means algorithm. Now we want to evaluate this solution. We choose a number of anti-cluster, here is 3, and we apply an heuristic algorithm to solve the anti-clustering problem. For each of these 3 anti-clusters that we create, we then solve the clustering problem and we obtain their WSS. By summing the WSS of each subset, we can hence obtain a lower bound for the whole problem. Also, starting from this partial solution, we can also obtain a new solution for the original clustering problem. And for example, this solution here provides a gap of 8.59%. Of course, the higher the number of anti-clusters, the lower will be the total time of the method, as the number of points per anti-cluster is lower. On the contrary, the lower the number of anti-clusters, the more accurate will be the lower bound. Our experiments show that the approach can be used in large-scale datasets ranging from 3,000 to 10,000 data, and we obtain a certification gap ranging from 0.1 to 5%. We have plans for future study as we want to investigate on an iterative procedure to further refine our certification approach. If you are interested in hearing more about this project, please come to my poster session on Monday evening. Alternatively, following this QR code, you can find an online version of this poster, the project details, and a preliminary open access code. Thank you for your attention.